Okay, so I don't think we actually used the term cube before, but you guys definitely know what that is. It's a rectangular prism with all sides equal lengths, right? So like a dice are cubes. Okay, so the volume would be it's 2 centimeters cubed, right? That's 8 centimeters cubed. Okay, what if instead it were 6 centimeter sides? So 6 cubed, 6 times 6 times 6 is 216. Okay, ratio of the side lengths, that would be 2 to 6, which you can reduce just like a fraction. Okay, then the ratio of the volumes. Okay, this one might be a little harder to figure out what to reduce by. Okay, so the ratio of the volumes turns out to be 1/27. Okay, and then here is a different rectangular prism. This one is not a cube because the sides are not all the same length. Okay, so let's see. Doesn't really matter which one you call the width, the length, or the height. Okay, so I'll just do the bottom rectangle as the area. So the bottom rectangle is 5 times 3 is 15. And then that makes the height the 4. Okay, and then a different rectangular prism is twice as long in all dimensions. Okay. Okay, so same thing. Volume is going to be area of the rectangle times the height. So again, I can do 10 times 6 is 60 inches squared for the bottom rectangle, times 8 is going to come out to 480. Okay, and then I asked how do their volumes compare? So I'm going to do a ratio again. 60 inches cubed to 480 inches cubed. Okay, so the inches cubed part can cancel out. 60 divided by 480, you can divide both by 10 to get rid of the trailing zeros, and then by 6/6 becomes 1/8. Okay, so the ratio of the volumes is 1 to 8. Okay, so let's look back over here. When the ratio of sides is 1 to 3, the ratio of volumes is 1 to 27. Here, the smaller rectangular prism is doubled. The sides are doubled, and then the volume is 8 times. Okay, so how does 1/3 become 1/27th, or how does 1/2 become 1/8? Yes, Joey? No, it doesn't. If you wrote 8/1 here, or if you wrote 3 and 27 over here, that's fine. Yes, sir. Yusuf? Yeah. Okay, so let's just say we went with 1/3 and 1/27. And then, okay, I'll do it upside down. Let's say that it was 2 to 1 and that became 8 to 1. Okay, so what pattern do we see when comparing the side length ratio to the volume ratio? Yes, Maya? Okay, so it's cubed. 3 cubed is 27, 2 cubed is 8. Okay, so if the corresponding sides of two similar figures or radiuses or diameters, if they compare in any ratio m over n, as Maya just said, to get the volume ratio, you instead do m cubed over n cubed. Okay, so let's summarize everything at the bottom where you have a little space. Okay, so there's 3 different ratios to consider. There's the dimension ratio. Okay, so again, a dimension is any single straight line. It can be a length, it can be a height, it can be a radius, and there's many others. I'm not going to list everything. Okay, that's one ratio. There's also what we call the area ratio. So this would also be for surface area. And then, so surface area is like, if you wanted to figure out how much wrapping paper it takes to wrap a box, right? The wrapping paper itself, if you lay it flat, it becomes 2D, even though it wraps a 3D object. Okay, and then lastly, we have a volume ratio. Okay, so we'll also group weight with volume. Okay, so the dimension ratio is some number m to some number n. Okay, and this is for any shape, whether you're comparing 2 circles, 2 triangles, 2 cubes, whatever. Okay, then to get from the dimension ratio to the area ratio, you square both numbers. So the area ratio is going to be m squared to n squared. Okay, and then lastly, the volume ratio, as we just saw, is m cubed to n cubed. Okay, so you need to know these. So how these problems will typically work is you'll be given one of these 3 things, and then you'll have to switch it to one of the others. Okay, and then sometimes you'll need to do an additional step after that. But yeah, being able to switch between these 3 ratios is important. Okay, so let's go and look at question 1 together. A triangular pyramid has height of 10 meters, volume 50 meters cubed. A similar pyramid has a height of 15 meters. What is its volume? Okay, so the first pyramid, we know both its height and its volume. Okay, so right now we could potentially do either the dimension ratio with the height or the volume ratio with the volume. Okay, but what are we comparing it to? The similar pyramid, we only know the height. We don't know the volume. Okay, so since you know both shapes' heights, you're going to want to create a dimension ratio. Okay, so dimension ratio is always m to n. And then you find m and n from that specific problem. Okay, so again, in this problem, the 2 heights that you're comparing are 10 and 15. Okay, and yes, you could do 15 to 10. I'm just going to do it in the order the problem listed them. Okay, and like any fraction, you can reduce. So let's just go ahead and reduce. Okay, so we know that for this problem, the ratio of the shape's dimensions, specifically their height, is 2 to 3. Okay, but now this question is asking us for the volume. So the dimension ratio is not going to be what we use. We need to find the volume ratio. Okay, so we're going to convert the dimension ratio to a volume ratio. Okay, so volume ratio is m cubed over n cubed. Okay, so again, we already are here. So let me copy that. Oops, sorry. And our goal is to get m cubed over n cubed. All right, so this is technically what we're trying to do, right? We're trying to figure out what is the volume ratio, what is m cubed over n cubed. We'll use the dimension ratio to create the volume ratio, right? You have m and you want m cubed, so you have to cube every part. Okay, so every single part of this proportion, you're gonna put an exponent of 3 on it. Okay, so m cubed, n cubed, 2 cubed, 3 cubed. Right, you're allowed to do that because you're treating all parts of the equation equally. Okay, so the left side, right, the whole point was to create m cubed over n cubed, which we now have. And now you simplify over here. 2 cubed is 8, 3 cubed is 27. Okay, so for some problems, we might stop right here. If the question was simply, what is the ratio of volumes? The answer would be 8 to 27. Okay, but the question wasn't, what's the ratio? You're actually finding the shape's volume itself. Okay, not how it compares, but the actual number of meters cubed. Okay, so now we're going to take the volume ratio and set up a proportion. Okay, so I'm going to continue over here. Okay, so take that ratio you just found out, 8 to 27, and set it equal to a blank fraction. Right, a proportion means you're setting two ratios equal, and in this case, two fractions equal. Okay, so what do we fill in the other fraction with? Well, there's a number we haven't used yet. We haven't used the 50 yet. Okay, so now that we have a volume ratio, we can bring in the volume that they told us. Okay, but you have to know whether the number goes on top or bottom. And it's not going to be the same for every problem. Sometimes it's top, sometimes it's bottom. So how do you know? Well, for the ratio, there's always going to be a bigger number and a smaller number, right? So for this particular problem, you can clearly see the smaller numbers up top and the bottom number is the bigger one. Okay, so that means that over here, the smaller shape is on top and the bigger shape is on bottom. Okay, so for this whole problem, smaller numbers up top, bigger numbers on bottom. Okay, so when you look at the 50 meters cubed, you need to figure out, is this part of the small shape or the big shape? Okay, so read through the problem again and see if you can figure out where the 50 should go. Okay, so the 50 meters cubed is the volume of the 10-meter tall pyramid. The other pyramid is taller. Its height is 15. So the 50 is the smaller pyramid. Okay, so the 50 will go up top because that's where the small numbers are going for this problem. Okay, and then the unknown is, what is the volume of the bigger pyramid? Okay, so this is the proportion. You should only have one variable. To solve proportions, we can cross multiply. So on this diagonal, we have 8 times x. And you set that equal to the product of the other diagonal. All right, so 8 times x is just 8x. 27 times 50 meters cubed is 1,350 meters cubed. Okay, and then divide both sides by 8. Okay. So the bigger pyramid has volume of 168.75 meters cubed. Okay, so questions on any part of this problem? Okay, let's go ahead and do one more together. Okay, so question 2. The triangular prisms are similar and the ratio of A to B. So A is this side length, B is this side length. Okay, so that's 5 to 2. Okay, so that's a dimension ratio, right? A and B are side lengths. Okay, and then we're told that the volume of the large prism is 250 centimeters cubed. Okay, so what happens all the time is students want to do 5 over 2 equals 250 over x. That doesn't work because the 250 is a volume, and this ratio cannot be used for volumes. This ratio can only be used for dimensions. Okay, so we need to convert the dimension ratio to a volume ratio. Okay, so use what you had, use the dimension ratio. But to turn it to a volume ratio, you need to put a power of 3 on everything. Okay, so the ratio that we're going to use will be 125 to 8. All right, so now we can set up a proportion. 25 over 8 equals something, some other fraction. Okay, so for this problem, the big number's on top and the small number's on the bottom. Okay, so now we decide where does the 250 centimeters cubed go? This one is for the large prism. All right, so for this problem, the bigger shape is on the numerator. And that means the unknown is the denominator. Okay, so it's not always on top. Sometimes it'll be on bottom. Just by coincidence, the 2 examples were both on top. Okay, so now that our proportion is set up, we cross multiply. Sorry, centimeters cubed, not squared. Okay, so sorry. Yeah, that's right. Okay, so the smaller cube is 16 centimeters. Or sorry, the rectangular prism has volume 16 centimeters cubed. Okay, so I'm going to give you a couple minutes to try out questions 3 and 4 of this section. So again, use what you wrote down below. Think about which of these 3 ratios did the problem tell us, and then which of these 3 ratios will be used to get the answer. Okay, and then you just convert from whichever ratio you started with to whichever ratio you need for the answer. Okay, so again, I'll give you guys a few minutes to try this out. Okay, so if I can make sure it's quiet, please, so that I can go over problem 3 and 4. All right, so for this problem, I tell you both volumes. Okay, so this time we're gonna start with the volume ratio. The first 2 examples, we started with the dimension ratio, but you can start with any of the 3. Okay, so one of them is 27 pi millimeters cubed. The other one is 8 pi millimeters cubed. And again, because these are volumes, these numbers represent m cubed over n cubed. Okay, again, on the previous problems, we started with m over n, but this problem, we're starting with the volumes. Okay, so let's reduce. The units can cancel out, and the pi's can also cancel out. Okay, so now we're at m cubed over n cubed equals 27 to 8. All right, so now what are we trying to do for this question? The question is, how do their radii compare? Okay, so the radiuses are straight lines. So the real thing we're trying to find is, what is the dimension ratio? Right, because when I say compare, that means that we are making a ratio. Okay, so the end goal for this problem is to get m over n. Right, that's all we're asked to do, is find the dimension ratio. So we need to take the volume ratio and end up with a dimension ratio. Okay, so if you compare the left sides, we need to go from m cubed to m. So the way to cancel out an exponent of 3 is to cube root. And you do the same thing for all 4 parts of the proportion. Okay, and that's it, right? We found the dimension ratio m over n equals 3 to 2. Again, if you put 2 over 3, that's okay. Okay, for this problem, we don't do the extra step. We don't set 3 over 2 equal to another fraction, because they asked us for the ratio itself. Okay, and last one, a box has volume 480 centimeters cubed. A similar box is constructed with sides that are half as long. Okay, so from that sentence, sides are dimensions. They are single lines. Okay, so this sentence is telling you that the dimension ratio you can either say 1 to 2 or 2 to 1. I'll just say 1 to 2. Okay, now what do we do with this? Well, the end goal is to find a volume. We can't use a dimension ratio for volume. We need to switch it to a volume ratio. Okay, so our end goal is to find the volume ratio m cubed over n cubed. And we will alter the dimension ratio in order to do that. Okay, so you just focus on this side. What do you do to m over n to make it into m cubed over n cubed? You cube it. You raise everything to the 3rd power. So you have to do it to the other side also. 1 cubed is 1, 2 cubed is 8. All right, so the volume ratio is 1 to 8. If the question is, how do the volumes compare, you would stop right here. You have the volume ratio, but here you're finding the actual volume, not just the ratio. Okay, so take that 1 over 8 and set it equal to a new fraction. Okay, and then what number haven't we used yet? We haven't used the 480. Okay, so do we put the 480 up top or on bottom? Well, obviously out of 1 and 8, 1 is the smaller number and 8 is the bigger number. Okay, so the 480, is that from the smaller box or the bigger box? Well, the 480 is the starting box, and then the other box has sides that are half as long. So the other box is smaller, so the 480 is bigger. Okay, so for this proportion, the small numbers go up top, the big numbers go on bottom. Since the 480 is from the bigger box, we put the 480 on bottom. Okay, and now we can cross multiply. All right, so again, sometimes you're asked for just the ratio. Sometimes you need to take that ratio and set up a proportion to solve for an individual measurement. Okay, and so this last set of problems is more practice. Okay, so it's not just volume. We're also going to bring back the area. Okay, so again, use this info to answer the last set of 6. Okay, so I'll give you guys a good amount of time to practice.